Hey guys, I have a new setup for my honors conversion videos. And now we're going to be doing an example that is quite similar to the one on the first set of um, practice problems that we had from the chapter 1 examples. So this would be just like 22.3.15. Okay, so now basis is we have this line, right? Oh, that didn't look very good, but it's all right. We have 4 different points. This is our positive x direction. And we're going to say that this is at 14 cm. We're going to say that this one is an 8 cm. This one is at 5. And this one is at 1. Okay. And so our first step is that we need to determine actually, I forgot to give you the rest of the details. This has a negative 2 Q charge. This has a plus Q charge. This has a plus 3 Q charge. And this has a negative Q charge. And our question here wants to find the E field at x equals 12 cm. So we want to find that right there. What's the E field? And this is given that Q is equal to 4.6 nanocoulombs. So here's what we're going to do. Our E field here, we're going to have to determine the directions. So this is going to be here to here is going to be negative from 1. So negative for this one. From here to here is going to be positive. From here to here is going to be positive. And from here to here is actually positive as well. So what we're going to have to do, E total, is going to equal negative E 1, 12, positive E 5, 12, positive E 8, 12, and positive E 14, 12. Okay, so this is simple, given that our Q is given at 4.6 nanocoulombs. So we just could do the standard, looks like the Coulomb's law formula. We're going to have K, the absolute value of Q over the radius squared. And we're going to do this for all of them. So when you do that, that's going to be negative This is going to be positive. Oh, I should probably, uh-oh. That's negative 2 cubed, so negative 2, that's a negative 2. This is positive q r squared. Okay. 3q absolute value. It's not pretty, but you get the idea. And over r squared and plus, okay, negative q r squared. And I'm going to, let me see if I can insert a text box here. Because I feel that'll be easier here to type out than to draw it. So this will be negative 8.99 times 10 to the 9th times the absolute value of negative 2q. So I'm going to go ahead and put this in right here as an I, absolute value of negative 2 times 4.6 times 10 to the negative 6th. And that's going to be divided by r squared. So to find what r squared was, that'll be that'll be 11. That'll be negative. Then we will have positive. K, so 8.99 times 10 to the 9th. Going to go ahead and multiply that by the absolute value of Q, which is 4.6 times 10 to the negative 6th. And then we're going to be dividing by r squared, which in this instance is 7. So 7. Then we will have positive for this next term. 8.99 times 10 to the 9th. Uh-oh, it's running off. Let me see if I can fix this. Times the absolute value of 3q, so 3 times 4.6 times 10 to the negative 6th, absolute value sign, divided by r squared. So that'll be, in this instance, 4. Oh, brother, let's see if I go down a size. Okay, so that's for our first 3 terms. I'm going to add my 4th term down here. Draw it. I'll just draw it like this. and this will be plus for our last term. So 8.99. Absolute value of negative q, so negative 4.6 times 10 to the negative 6th divided by r squared. And our r here is 2. Let me go ahead and see if I can do, I'm going to go ahead and color code this for you here. So this right here is this term. This right here is this term. This right here is this term. And this term right here is this term. And I actually don't know the answer to this, but I'm going to go ahead and calculate it out here. I'll make it black here. E total will equal times 10 to the 9th. Putting it in my calculator here. R squared, so our R here is 11, so 11 squared. So our answer here comes out to about 1,024. That's for part 1. For part B, go ahead and draw it. Again, apologies, this is my first time doing this system. I'm sorry, by the way, I forgot to note at the beginning of this problem that these measurements are in meters, not in centimeters. They're in meters. Our final thing is we need to find the energy actually,